In this video, we're going to continue our work with numerical methods and look at iteration. Iteration uses the limit of a sequence to find a solution to an equation. Let's see how this works. If we take a function of x, and we'll use the one that we had in the last video, f of x is equal to cos x minus x. If we set f of x equal to 0, we can rearrange the equation to the form x equals the g of x, where the g of x is a different function. So let's go ahead and do that. Let's write this, f of x is equal to 0. Therefore, we can say cos x minus x is equal to 0. So I could now write this as x is equal to cos x. This is now in the form x is equal to the g of x. Now, g of x is cos x, and we can see that that is a different function. At this stage, we look to form a sequence. It may be that the iterative formula or recurrence relation x sub n plus 1 equals g of x sub n produces what we call a convergence sequence, i.e. it tends to a limit. If it does tend to a limit, then that will be the solution of the equation f of x is equal to 0. So what we do is take now x equals g of x and write it as a recurrence relation. So we can write this now as x sub n plus 1 is equal to g of x sub n. We would be given x sub naught, and then every iteration after this would get closer and closer to the solution to the equation f of x is equal to 0. If and only if now the modulus of the gradient now of g of x is going to be less than 1. And we'll look at that as we go through the video. So what we're looking for is a sequence that converges to a limit to give us now the solution to this equation. Not all rearrangements will lead now to the sequence converging. Some will end up diverging, and we'll look at that now in the next example. So let's take a function of x. Let's take the f of x is equal now to, let's say, x squared minus sine x minus 1. So what we want to do now is find a root. So we've got lots of different options now in terms of rearrangements. Generally in an exam you'll be led into one of the rearrangements, or they will just give you which form they want you to put this in. So if we set this equal to 0, x squared minus sine x minus 1 is equal to 0. So this is our first step. So we got the f of x is equal to 0. So one possible rearrangement now for x is equal to the g of x, we could have now that x squared, and add in sine x and 1 to both sides, x squared is equal to sine x plus 1. We could take the square root of both sides, and we could have x is equal to the positive root of sine x plus 1. So this now is one particular form that I could put it in. So if I wanted now the recurrence relation, I would have now x sub n plus 1 is equal to the square root of sine of x sub n plus 1, where x is in radians. So this is just one rearrangement that we could look at. Now this might tend to a limit and produce us now a solution to the equation. If we look at another possibility, we could say now that x squared, and starting here, x squared minus sine x minus 1 is equal to 0. We could say now from here that x, and we could write this like so, we could say now adding the 1, let's add the sine x to both sides, let's say now that sine x is equal to, and we will have now x squared, and then we'll have minus 1, so let's do that. So we can say x is going to be equal to the inverse sine, or arc sine, of x squared minus 1. So we could set up now the recurrence relation, or iterative formula, x sub n plus 1 is equal to the inverse sine now of x n squared minus 1, again in radians. So straight off I've looked at two different rearrangements now to get me x is equal to the g of x. One of these might now converge to the limit, one might diverge. If it diverges, we don't get now a solution. If it converges to a limit, we will do. In an exam, generally the questions are structured such that they will initially ask you to show that there's a root, alpha, and we call the root alpha, between 1 and 1.5. So we might have to show now that alpha, there is a root now, alpha, and we'll put alpha between 1 and 1.5. So all we would do is the f of 1, and then we would do the f of 1.5. So what we want here now is a positive and a negative value. And we would state now that we've got a positive and negative change of sign in a continuous interval. Therefore, there's a root alpha now between 1 and 1.5. And this is something that we looked at before. So let's just go ahead and do that and then move on to the question. So shift mode 4, put this in radians mode. So what we're going to do now is sub in 1. So what we'll have then is the following. And I'd just like to put this in 1 squared. Then we've got minus now the sign of 1. Let's put that in there. And then we've got now minus 1. So what does that give me? That gives me negative 0.84. So that's going to be 0.84 dot 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 and so on and so forth. And then if we put in 1.5, so let's just switch this over. We've got now here 1.5, and then we'll put 1.5 in, and we want to show that this is positive. So this would be the first step often in the equation. We might just be given x sub naught and asked to look at these. So there we go, we got 0. Let's put this in 0.25. So what we could say then, this one is negative, this one is positive, and then we've got a change now of sign in a continuous interval. So change of sign in continuous interval, therefore alpha is going to be, there is going to be a root between 1 and 1.5. Okay, so let's look at these now. What we would be given now is x sub naught, and then each iteration will lead us, if this converges closer to now a solution to the equation that we got here, that f of x is equal to naught. So let's say we were given now that x sub naught was equal to 1. Let's just make this nice and straightforward. So what we do on a calculator now, and I'm going to choose this one first. So what we're going to do is put 1 in. With these calculators, you can use your answer button. So I'm going to hit equals now, and this is in as 1. So my iterative formula is going to be the square root now of sine of my answer, and then we're going to have plus 1. What this is going to do is first work me out now x sub 1, and generally we have to list these out. So this is going to give me the first approximation. So if I look now at x sub 1, I simply hit equals, and that gives me 1.357. So let's put this in 1.357 dot 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 and so on and so forth. So that's now my first approximation after x naught. I'd then look to x2. Often you'll be asked to give x1, x2, x3 and so on and so forth, and it would probably just go up to x5. What this is now going to do is feed in the answer to get us now a better approximation. So if I now put this in, if I hit now enter, it will put that in, and that's going to give me now 1.406. So 1.406. Okay. Now, this is going to take 1.406 and put it in. This is a recurrence relation, and you would have come across these before. So it's feeding the answer back in, and we're looking now at generating this sequence that will tend to a limit. Once we can get that limit, then we're going to have now a solution to the equation of f of x is equal to 0. So if I hit now enter, I get 1.409. So let's put this in, that's x sub 3. So that's going to be 1.409 dot 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 and so on and so forth. Now if I keep going with this, what it's going to do now, you can see that it's tending to this number here. So I'm going to press it again, and then it's hit now this limit here. So what we could say now is that the solution to the equation is going to be 1.40962 and so on and so forth. And that's what we would have. So we would just write this down now, and again, you would be asked to find now x sub 4, x sub 5, and then you might be asked to show now that this is correct to, say, 4 or 5 significant figures. And we will look at that as we go through the video. So that one does work. So that now has converged to the limit, and we can say that this is going to be, and I'll write this now to 4 decimal places. Let's write this as 1 point, and then we got 4096, and that's now to 4 dp. Okay, so that one now is going to converge. And again, if we think about this, in this particular interval close to the root, we need to ensure that the gradient is going to be less 1, or the modulus of the gradient, and we'll look at why shortly. Now let's take this one just here. So again, taking x sub naught to be our first point. So what we're going to do is sub this in. So back through the calculator, you press 1 and then equals. This is now your answer. So I'm going to set up the inverse sign now of my answer squared, and then I'm going to subtract 1. So what we're going to have then is the second one. So this is now going to give me x sub 1. So x sub 1, and all I have to do is hit equals. That's going to give me 0, okay? Now if I do the next one, I'm going to end up now with minus pi by 2, which is minus 1.57. So let's put this in, minus 1.57. Okay, so now let's do the next one. We're going to get a math error. So you can see now that that is not giving me a value. So this is not going to find me a root. This has ended up diverging. So we can see that this arrangement is leading to a root and this one isn't. If we looked at different rearrangements of the original equation, this might lead us now to the other roots. So you can see there's plenty of scope for writing x equals a g of x in different forms. What we've got here now are two different arrangements. When we look at this graphically, we've got 4 different scenarios, and we're going to look at these 4 different scenarios. So I've managed to find this in a book, and it shows what we have. So right here, we have now this example here. So we've got now the gradient, and the gradient is going to be between 0 and 1. So this is going to converge. So we can see that we've got x sub 0. This would be our first now value, and that's what I looked at with 1 in the last. We would go up to the curve as our first point. Then this would provide us now the value of x. So that would be our first approximation. What we then do is feed that in. So we take x sub 1 to be the next one. We go up to the curve and move left. This gives me now the second one. I come down, I feed that in, and we can see now that we're moving closer in to the solution. And the solution alpha is just here. So what we have here now is what we call a staircase. So this is a staircase that is going to converge, and this is the graphical representation. So we can see now that it's getting closer and closer, and then it will hone in on this root. And that's now because the gradient is between 0 and 1. If we look at this one though, we've got a gradient greater than 1. So if we take now x sub 0, we go up, and then we move across to the line. This becomes now x sub 1. X sub 1 goes in, we go up to the curve, and that becomes now x sub 2. And you can see what's happening. When this goes in, it's going to diverge and now simply get bigger and bigger without limits. So, or without a limit. So this is going to diverge, and it's not going to produce us now a solution. It's not going to tend to a limit, therefore it's not going to give us a solution to f of x is equal to 0 as it's diverging. The other one is what we call a cobweb. So with this one now, we've got the gradient between -1 and 0, and we're going to end up finding our root. And you can see how this is honing in on the root. So what we do is take now x sub 0, we come up to the curve, and that gives us our first value. We go across, so that gives us now x. We then put x into the function, and we go up to the curve. We go to the line, that gives us x sub 2. We go back up to the curve, and then we get now x sub 3. We come down and we put it in, and it's going to now find the root. And you can see why it's called a cobweb. This is going to go round and round, and then eventually come in and land on this root just here. And that is the limit of the sequence. We can see in this particular case now that the gradient around the area of alpha, which is our root, is going to be less than -1. So what we're looking at is essentially in this case f dash of a being now the modulus. It will now converge if this is less than 1. And we can see that here. That's a case of it here, and that's a case of it here. It's not here. So this now is going to diverge, and you can see on from this, from the cobweb, that we're simply going to be moving further and further away, and often you'll end up just having the math error on the calculator. So let's look at this with a function that we can at least get our head around and see what's happening. So what I'm going to do now is graph the following. So let's look at, let's take the f of x. Let's take the f of x is equal to, let's just do x squared minus x. Now straight off we could go ahead and solve this. So if we set this equal to 0, so what we'd have is x squared minus x is equal to 0. Factoring now, what we're going to have is the following. We're going to have x x minus 1 is equal to 0. So we can see that x would be equal to 0 or x would be equal to 1. And we can solve this algebraically. Now, what I'm going to do is let now f of x be equal to 0 and rearrange this to x is equal to the g of x. So let's say we got the f of x is equal to 0. So what we could say then is x squared minus x is equal to 0. So at this stage, I could say x is equal to x squared. So now what we have is g, now we've got x is equal to the g of x, now where the g of x is x squared. So I could set up the iterative formula x sub n plus 1 is equal now to x sub n squared. So what we're going to do is look at this. Now, what's happening here, and I'll just draw this up. Let's just draw this example. So this now is one possible way that we could look at this. We're going to have now the following. We're going to have the parabola. So this is going to be x squared. So we're going to have x squared. And then we're going to have the line. And it's not brilliant, but hopefully you can see what's happening. We have the line y is equal to x. So this is what we've got just here. Now, I've rearranged this into the iterative formula. So once it's in x is equal to g of x, I've said now that we're going to take x sub n plus 1 is equal to x sub n squared. Okay, let's take x sub 0 to be equal to, let's say, 0.4. So what we're going to do is take x sub 0 equal to 0.4. So what I'm going to do is try and use this rearrangement here and then now the recurrence relation to find now a solution to this equation. And we know what the solutions are. We know the solutions are going to be 0 and they're going to be 1. So what we've got then is x sub 0 is equal to 0.4. In our calculator, we put now 0.4. So let's get a shot of that. And 0.4. That goes in. So what I'm going to do now, if we look at our recurrence relation or our iterative formula, I'm going to take now the answer squared. So my answer squared is going to end up to be 4 over 25 or 0.16. So that's going to be x sub 1. So x sub 1 is going to be 0.16. Now, this is going to feed 0.16 in. So essentially what I've just done on here now is the following. I've taken 0.4, and let's put 0.4 there, and we've gone up like so, and then I'm going to end up, and in fact, I'll just move this along. It's slightly inaccurate, but hopefully you'll see now what's going to happen. Let's say that point is going to be 0.4. So we've taken this up to the curve, and then we simply draw across. And in an exam, you wouldn't do this. You would just be given now the iterative formula and you just plug values in. What we're going to do is go across now to the curve. So this is going to give me the 0.16. I'm now going to drop the perpendicular back down, and this is going to become now x sub 2. So what we then do is come back up, and we're going to end up now coming to the curve just here, and we're going to read off. So what you can see is we're creating now a staircase, and that staircase is going to get towards the root. So this was giving me now, this is my x sub, let's put this in, so this is x sub 0, this is going to be x sub 1. So let's now hit the enter again, and this is what you're doing in the exam, you're just hitting enter, and that gives us 0.0256, so let's do that. So x sub 2, 0.0256. So now what we've got is the second one, and we can drop a perpendicular down. And as stated, this is kind of a bit sketchy, but hopefully you can see what's going to happen. So this is going to now give me x sub 2. We're going to feed that in, and we're going to come back here. So you can see that it's staircasing now to this root. So using this arrangement here, let's put in x sub 2. So here's x sub 0, x sub 1, x sub 2, and we can keep going. Now, quite clearly, I'm not going to be able to graph that. So this rearrangement is going to now give me the root 0. So let's go ahead and just keep going with this. So we end up with the next one, which is that one, the next one, so that would end up being x sub 4, and we could keep going, and we could keep going, and you can see now that ends up tending to 0. So the limit of the sequence is 0, and that gives us now the solution, and that's what we were expecting. So that sorted me out for this root here. Now, if we think about this one here, what we've got now is it's not finding this root. So what we'd need to do is a different rearrangement. And the reason it's not finding a root now is the gradient at this point. If you think this is x squared, the gradient is going to be 2x, which means the modulus of gradient is going to be greater than 1. So what we need to do is consider now a different rearrangement. So let's go ahead and try and locate this root here. Let's say we've got x squared minus x is equal to 0. That's what we had just here. So what we could say now is, let's say x squared is equal to x. Okay. So now just writing this the other way around. Let's just make it slightly easier to see. Let's just write it like so. So in fact, we've already got that. Let's just scrub that out. What I'm going to do is take now the square root of both sides and have the positive root of x. So we've got now x is going to be equal to the positive root of x. So I've got this in the form x is equal to the g of x, where g of x is going to be the positive root of x. So our second rearrangement, x sub n plus 1, could be the square root of x sub n. So let's have a look at what we're going to have with this particular rearrangement. And again, the reason I'm doing this is because these are graphs, or at least things that you can kind of get your head around and associate with. The positive root of x is going to look something like so. So if I went ahead and drew y is equal to x on this, let's do that. Y is equal to x is going to look something like that. And again, that's not massively accurate. We're going to just go through here. Let's just make this a bit better. Let's make it do that. So there we go. That looks okay. So what we're going to do again this time is pick an x sub naught. Okay. So what we're trying to do is essentially find the other root, which we know is 1. So let's say now that x sub naught, let's say x sub naught. So x sub naught is going to be equal to 0.7. So what we're going to do in the calculator is 0.7. So you always put x sub naught in and hit now equals. Setting up the recurrence relation or iterative formula, I'm just going to put in the answer squared. So x sub 1 is going to give me this right here. And we would be expected now to write these out. So if this is going to converge now, these are going to be better approximations to the root here. So 0.8, and what have we got? 3.6, 3.6, and so on and so forth. Okay, I'll just scribble those down. You will be expected to give these to a high level of accuracy. So in the exam, often just writing your calculator display is ideal. So we've taken the first one, and you can see with this one, again, we're going to be staircasing in, but we're going upwards this time. So I've taken x sub 0 to be here, so we'll go up, we'll go across, we'll go up, and then we'll take now x sub 2. So let's do x sub 2, and x sub 2 is just hitting equals again. So that's going to give me the 0.9, what was it, 0.91, 914, and so on and so forth. Again, writing these out. So the next one is going to be now our third better approximation. So let's put that 956. That's x sub 3 is equal to 0.956. Now, it won't always be the case that these are in a linear form, and it will with these staircase, but sometimes they'll oscillate. And do be aware of that. Let's just keep going with this. And as you can see now, what's happening? That's going to get closer and closer to where we want to go. So you can see now that I'm just simply doing more and more iterations, and eventually now that is going to tend to the limit and give me 1. And that finds our root. So hopefully that example right there has made things slightly easier for you to understand with now an equation that you would know. And 2 different arrangements have found me my 2 different roots. So there we go. That's a basic example right there. Okay, so let's look at a typical exam question that we might be given. Let's see what we can do. Okay, so we've got the f of x is equal to 3x multiplied by e to the x minus 1. It says the equation f of x equals 0 has a root between 0.25 and now 0.3. So we've got this root alpha. Generally, we will call the root alpha. Now, it might ask us to show that. It hasn't in this question, but if we needed to show that, all we would do is the f of 0.25 and now the f of 0.3. And we would show that one is positive and one is negative, and we would conclude with there's a change of sign in the continuous interval, therefore there's a root alpha between now 0.25 and 0.3. So we're not asked to do this, but let's do it anyway. Let's do 0.25. So what we've got then is 3 lots of my answer now multiplied by, and then we'll have now e, let's put in e, to now our answer, and then we'll subtract away 1. So what we're going to have with that one, we've got a negative number right there. And then if we did now for 0.3, so let's take 0.3, we want this to show now this is going to be a positive number. So 3 answer multiplied now by e to my answer, and then we'll subtract away 1. And that's going to give us now a positive number. So this one, and we would have to write these down, this one is negative, this one is positive, we would say change of sign in continuous interval, and then we could say in continuous interval, therefore alpha, our root, and generally we have alpha, is going to be between now 0.25 and 0, let's put 0.25 and 0.3. So that's generally what you'd get asked in the first part. Okay, it's telling me to use the iterative formula, x sub n plus 1 is equal to 1/3 e to the negative x sub n, with x sub 0 equal to 0.25, to find to 4 decimal places the values of x sub 1, 2 and 3. So what this is saying now is x sub 1, 2 and 3 are going to be better approximations to the equation of f of x is equal to 0. Okay, now if we didn't have this and it wanted us to show that it could be written in this form, all we would do is simply go ahead and write now the f of x is equal to 0, and we would look now to express x equal to the g of x. So what we'd have is 3x e to the x minus 1 is equal to 0. Now I strongly suggest you let them guide you on these. So if they're telling you to get that into this form, which I often do in an exam question, just have a look at it. So what we're going to do now is the following. I'm going to add 1 to both sides. So we're going to have the following. We're going to have, and I'll write it as 3 now x e to the x will be equal to 1 by adding 1 to both sides. Now at this stage we can divide both sides now by 3e now to the x. So we can have x is equal to 1 over 3, and then we're going to have e to the x. Now e to the minus x is just simply 1 over e to the x. So x would be equal to 1/3 e to the minus x. So they've just set up now the recurrence relation or iterative formula. X sub n plus 1 is equal to 1/3 e to the minus x sub n. And we're given now that x sub 0, which is our first approximation, is 0.25. So what we want to do is get x sub 1, we want now x sub 2, and we want x sub 3. So straight off in the calculator, what I do is put in 0.25, so 0.25. Okay, now I feed this in, so I set up my iterative formula, and it's simply now what's on the right hand side. So we've got now, and I'm just going to put this now as 1 over 3, and then we're going to have now e to the answer. This is the same as what they've got. They've got e to the minus answer, which is exactly the same. You can put e to the minus answer, or you can just have it in the form we have it here. So this is going to give me my first approximation. So I need to give this to 4 decimal places. Generally, you'll be expected to write this out and round it. I'm just going to give it to 4 decimal places straight off. So that's 2596. So 0.2596. So this is a better approximation to the last one. What we now do to get x sub 2 is just hit enter or equals again. So 2571. So let's put that in, 0.25, what was it, 2571, so 2571. Okay, let's now look at the next one. Let's go ahead and do that. So what have we got? 2578, so 0.2578. Okay, so we could keep going with this. Okay, if you kept going, we're not asked to do that, but you can keep going, and you can see now that it's tending now to this limit right here. So this would be the solution. Okay, in the next part it says part B, by choosing a suitable interval, show that the root of f of x equals 0 is x is equal to 0.2576 correct 4 decimal places. What we look to do here is the upper and lower bounds. So we're going to consider the upper and lower bounds, and we need to be fairly tight in terms now of what we choose. And we looked at the reason for that in the first video. So if we look now at the lower bound, we're going to 4 decimal places. So the lower bound is going to be 0.25, and then we're going to have 755. So we're interested now in this, and I'll just write it here. So this is the lower bound, and then the upper bound is going to be 0.25, and we're going to have 765. So this is the upper and lower bound, and I just like to now do it as such. So what we want to do is show the f of 0.25755 gives us now one side of the positive, and then the other gives us the other. So one's positive and one is negative. So let's go ahead and evaluate these. So what we're going to do is the f of 0.25, and then we're going to have 765. 5. So what we want to do is show a change of sign in the continuous interval, therefore our root alpha is 0.2576 correct to 4 decimal places. So let's go ahead and do that. So what I'm going to do, and this is putting it back through the original. So let's do that. This is what we've got. So let's grab the calculator. So I've got now, and I'll do the 0.25755 to begin with. So let's put that through. So we've got now 3 lots of the answer multiplied now by e to the answer. Let's do that one, and then let's subtract away 1. And we are going to end up now with negative 3.79 times 10 to the 4th. So negative 3.79 times 10 now to, what was it, 10 to the minus 4. 10 to the minus 4. Okay, let's now go ahead and show the other one. So we're going to see this is going to be a pretty small number. Let's do the next one. And you can do this any way you want. You can change the numbers over, or you can just plug in a new answer value. So I'm just plugging in a new answer value. So we've got 2, 5, and then we've got 7, 6, 5. So that's the upper bound. Okay, so what we're going to do now is plug this in. So let's go back up to this one, and we can do 3 lots of the answer multiplied now by e to the answer, and we're going to subtract away 1. So we want this to be positive and quite small. So 1.09 times 10 to the minus 4. So 1.09 times 10 to the power of minus 4. So what we now do is conclude, and we say change of sign in continuous interval, and you will have to write it all out. I'm just shorthand, continuous interval. Therefore now alpha is going to be 0. And then we've got our value just here, 25, so 0.2576, correct now, alpha is equal to that, correct, 2 now 4 dp. So we've shown a change of sign in the continuous interval. So let's take this back now to the first video and see what this is doing. Essentially what we've got now, and in terms of what the curve looks like, we're not 100% sure. We could have some idea, but if I just drew it anyway, let's just draw some curve, and this is just any curve. What we've shown then is the following, and if we take this point just here and this point just here, this now is 0.25755, and this one is 0. Now, and we're going to have 25765. So we can see now, if I evaluate here, we're going to get a negative number. If I evaluate here, we're going to get a positive number. Therefore, alpha is somewhere in between there, and that's now correct to the 4 decimal places. So we're showing a change of sign in this continuous interval. So it's not discontinuous like 1 over x, we're just showing that that's the case. So there we go, that is a typical exam style question. So in terms of actually knowing how this works, the question is, do you need to know, do you want to know? But ultimately the vast majority of exam questions are of this form. They give you what you need to do. They give you x sub 0, or sometimes they just call it x sub 1. You find now x sub 2, 3, 4 and 5, and then just show now that there is a root by evaluating the upper and lower bound through the original function. So there we go, that's a brief introduction to iteration. So solving now equations using iteration. In another video, I'm just going to work through some basic exam style questions to show you how formulaic you can see this whole topic. I'd like to have a deep sort of thought into how this works rather than just number plugging. But in terms of a topic, it does lend itself well to just putting a number in a calculator and hitting enter all the time or equals. But I think some understanding of how iteration works is beneficial.